Hi! In general, rotary encoders are used in many projects. For example, navigating in menu or changing numbers, etc. But using them is not very easy because you need to track the each edges of the both square wave outputs in order to know the directions and the steps. Missing some of the edges means that the rotary encoder became unusable. We present I2C Encoder V2, an easy way to connect multiple rotary encoders. Last year, we have created the prototype of a small board to connect encoders on I2C bus. After having bring up its first version, now we have created version 2 that includes more features. For example, you can mount a normal rotary encoder or an illuminated RGB encoder. To connect multiple I2C encoder boards, you can mount a 2.54mm connector or a GST-XH connector. There are 5 castellated holes on each side. It allows the boards to be soldered together in every direction. There are also 7 SMD jumpers for setting the I2C addresses. It means that the address is fully customizable. There is no need to add external resistors on I2C bus. You can solder them directly on the board. There are also 3 configurable GPIOs organized with the same footprint of RGB LED. You can use these pins as PWM output, ADC input, digital input, or digital output. For example, you can mount an RGB LED or just solder some wires instead. I2C Encoder V2 has also 256 bytes of EEPROM. It's working between 3.3V to 5V. The board dimension is only 25 by 25mm. The I2C encoder has several features that simplify the user's life. In order to read the rotary encoder, there are 4 32-bit registers that can be used as integer number or float number. You can set a maximum and minimum thresholds, plus the counter steps value. At each encoder step, the counter value will be increased or decreased according to the counter step value, and its value will be inside the thresholds. In this example, the maximum threshold is 10 and minimum is -10, while counter step is 0.5. There is also the possibility to detect when the push button is pressed, released, or double pushed. There is also an auto fade feature that makes possible to have a fading LED effect without writing extra code. This is another example to demonstrate the usage of GP pins in the ADC mode. There are 2 potentiometers are connected to the GP1 and the GP2, and they are used in ADC mode. The analog value is shown on the display. This can be very useful in case you don't have any analog input available on your board. Here there are 9 I2C Encoder V2 are connected to each other in matrix 3x3. Each board has different I2C addresses. With the I2C bus, it's very easy to control each RGB LED and the rotary encoder. In case that you need to add one more encoder, you only need to connect and add few lines of the code. I2C encoder is compatible with Arduino family boards, Raspberry Pi, ESP8266 series boards, and many other developing boards. Thank you for watching.